Okay, looking at number 40 in section 3.5, it shows us the graph of the second derivative right here. And it asks us to look at figures A and B and decide which one's the graph of the derivative and which one's the graph of the original function. Now, one thing we know about when the second derivative has a zero, when it crosses the x-axis, then the first derivative is going to change. It's going to have, here, notice it has positive slopes, and then it has negative slopes, and the first derivative is actually going to have it's going to have a horizontal tangent line at that point. So it would have to be this graph to have a horizontal tangent line here, so its derivative crosses the x-axis. Notice the slopes are positive, and the slopes here are positive, and then the slopes are negative, which they are here, until it has another horizontal tangent line that corresponds with this place where it's the derivative of this function is 0. And again, here, this corresponds to this place where the derivative of the function is 0. So this one must be f prime, and so then obviously this has to be f, but you can see your little brain's going to be hurting. But okay, if this is the original function, then it's going to have the derivative of that function will have a 0 there, and notice that it does. And if this is the original function, it has a horizontal tangent line, so its derivative should cross, and notice it does, and then its derivative should cross about here, which it does again. So, and then also this idea of it, the derivative should be negative in here, and you can see that it is negative in here. So that's just a nice little problem, kind of getting you to see the connections between the graphs of the first, second, and original function. First, second derivative and the original function.